This is a video presentation of Chapter 1, Section 5 in the 7th grade textbook entitled Properties of Numbers. Okay, so let's go ahead and look at the 4 essential properties of numbers here that they're giving definition to on this first page. There's the commutative property. That's a property that states that you can add numbers in any order and multiply numbers in any order. Now, before we go on with the explanation here, let us remember that we have previously studied subtraction and division. And we've changed subtraction into adding the opposite, and we've changed dividing into multiplying by the reciprocal. And if you're having a hard time picturing that one, think of two fractions, and I think it will come to you. So as long as you change those, the only things we have to work with then would be addition and multiplication anyway. And what the property says is that I can change the order of the numbers around and still get the same result. For instance, 3 plus 2 is the same thing as 2 plus 3. Yes, different problem, but the same two numbers presented in a different order. Either way, the result is 5. That's what the commutative property says. The commutative property says I can change that order around and still get the same result. Now, there's the associative property. That's a property that states that when you add or multiply, you can group the numbers together in any combination. So what they're talking about there is either A, moving parentheses around in a problem to put different things together, or to associate different numbers, hence the name associative property, or inserting parentheses into a problem, which would then associate those numbers as well. And of course, by inserting parentheses into a problem, you already know that that would invoke the order of operations, which would mean I would have to do it first because it's the first step. What the rule states here is that if I'm adding a bunch of numbers or if I'm multiplying a bunch of numbers and I drop some parentheses in, the result is the same. Now, that is not an AND statement. I can't be doing adding and multiplying in the same line and say, I'm going to throw some parentheses down here and see what happens. Well, we already know that that's not going to work. If it's all addition, though, and I throw some parentheses in, or it's all multiplication and I throw some parentheses in, all right, I can do that and still come up with a correct or proper result, the same result as if I had not done anything with parentheses. And that's what the associative property is all about. The identity property is a property that states the sum of 0 and any number is the number, and the product of 1 and any number is the number. So the identity property is talking about what doesn't change a problem. What doesn't have any effect on the numbers in a problem. And indeed, adding 0 to a number or multiplying a number by 1, yes, while it is a problem, an actual numerical type problem, it doesn't change what you have to start with. 3 plus 0 is still 3. 7 times 1 is still 7. Yes, it's something to compute, but the answer is ultimately the same as what you started with. The distributive property is probably the trickiest of all, but a property we'll use quite a bit in the next several years here as you move through middle school and into algebra and geometry. That's a property that states that you can multiply numbers mentally by breaking apart one of the numbers and writing it as a sum or difference. A property that states that you can multiply numbers mentally by breaking apart one of the numbers and writing it as a sum or difference. Now, usually when we use the distributive property is when we're putting some numbers together like x and 7, a variable and a constant. And I want you to simplify that type of problem. Well, x plus 7 doesn't make anything other than x plus 7. But I can multiply it by something and it becomes something else. That's when you're going to apply the distributive property in the future. Right now what they're talking about is a problem like 32 times 7. Yes, of course, we could get a calculator out and do something like 32 times 7. But it's a lot easier if I do 30 times 7 and 2 times 7 and put those results together. And of course that would be the same thing because the 30 and the 2 go back together to make your original 32. But obviously 30 times 7 is a lot easier because it's 3 times 7 with a 0 at the end, and 2 times 7 on its own is actually a pretty easy problem. So if we put those results together, it's probably easier than figuring out something like 32 times 7. That's what the properties of numbers are all about. It's about taking a problem and doing something to it to make it easier using the ideas of mental math. And we'll be applying these properties throughout the examples here today.